Good morning to everyone. So today we are going to learn about determinate and indeterminate structures. So along with this, in previous lectures, we learned about the different structures, so analysis of different structures, so which are subjected to axial loads, and the load is applied at different locations, as well as the single load is applied on a structure. Such kind of problems we have learned in the previous lecture. So today we are going to learn about a numerical on member subjected to a axial load and constraint between rigid supports. In previous lecture we have gone through one numerical, so which is supported, rigidly supported between two supports. So today also we are going to learn same kind of problem with different geometries. And after that, so structural analysis procedure, what is the generalized structural analysis procedure? And we are going to understand today about what is a determinate and indeterminate structures, because in forthcoming lectures we are dealing with the determinate structures and indeterminate structures. So therefore we will gain some knowledge about what is determinate and indeterminate structures. So this is the problem. So today I am going to deal with the problem is like this: a steel rod 10 mm diameter and a aluminum rod 20 mm diameter are joined together fixed between supports as shown in figure. E for Young's modulus for steel is 200 GPa and Young's modulus for aluminum is 70 GPa. Find the reactions at the supports and the stresses in the metal. So here we have two rigid supports. This is one rigid support. We are referring this as A, and second is a rigid support B. So between these two, the two bars were fixed. One is made up of steel and another is made up of aluminum, and which is subjected to a load of 30 kilonewton at section C, or at point C you can call. The length of the steel is 250 mm and the length of second section CB is equivalent to 400 mm. Now as usual, so before starting the solution, so first of all we have to understand, so all the parameters, given parameters. For that it is necessary to write these parameters in the form of given data. So write this given in the form of given data. So because so here it is asked to compute, so it is not supports, I say find the reactions at the supports and stresses. To find the stress, so we need to compute the area. So only diameter is given here. So that's why first of all you write this given data. So diameter is given, diameter D1 is equal to 10 mm square. And here along with this given data, so I have computed the area. Area of steel member A1 is equal to pi by 4 into D1 square is equal to pi by 4. Its diameter is 10 mm into, so multiplied with pi by 4. So this is 78.55 mm square. Similarly, area for the member aluminum, so it is pi by 4 into D2 square. So that is pi by 4 into 20 square. It is it's about 314.15 mm square. And length of the member 1 is 250 mm. Length of the member 2 is 400 mm. And the load acting on the member is 30 kilonewton. So because all dimensions are in mm square, so here, so always we have to convert this in terms of Newton. 30 kilonewton, so that is equal to 30 into 1000, 30,000 Newton. And E for steel, it is 200 GPa. So always you convert this GPa in terms of MPa or Newton per mm square, because see here all dimensions are in mm. So and the above load is in terms of Newton. So therefore we have to write this in terms of Newton per mm square. So convert this GPa into newtons per mm square. 200 into 10 raised to 3 Newton per mm square. So you have to remember this. For aluminum, same 70 GPa. 70 into 10 raised to 3 Newton per mm square, or you can write simply 1 Newton per mm square is equal to 1 MPa. So you can write this in terms of MPa also. So it is better for understanding. Always you have to write in terms of same units. So I have converted all given data so in the form of single units. So that is Newton and mm. So once you have completed the job, the next task is to analyze this member. As we have discussed in the previous lecture, these two members are rigid, constrained between two rigid supports. Two rigid supports means even you are applying a compressive force on this, so this component, aluminum bar, will not move beyond this B point. So it is restricted. So because the reaction force is acting from this side, so due to application of this 30 kilonewton, this length of the bar shortens. Reduction in the length of the bar occurs. See, so this is the reduction in length of the bar, aluminum bar, BC section. So and simultaneously, so these two are fixed between rigid supports and the steel bar elongates. So due to application of this 30 kilonewton, so this end is fixed. So therefore this bar elongates. The elongation in steel bar is equal to, so I will write elongation or deformation. So one and the same. Elongation in steel bar is equal to elongation in aluminum bar. So only thing is aluminum bar shortens and steel bar lengthening of the steel bar occurs. This is the difference. But the change in length, delta L or elongation in steel bar, is equivalent to aluminum bar. See here, this is the region so which will undergo deformation and it is applicable. This much amount of distance it shortens and same amount of length it deforms. But this rigid connections, it remains same. This component will not move beyond point B and A. So it remains within this section. So this is the concept. Once you have understood this phenomenon, so now it's a very easy to solve the problem. Now for solving such things, so what we have to do here, there are two forces. One force is say the reaction force at A, because this is rigidly fixed. Reaction force is acting here. Say usually it is in the opposite to the direction. So this force is acting in this direction means this is subjected to tensile load. So it is the reaction force is acting here. I will write this reaction at A. And similarly, so this force on aluminum bar is acting in this direction, means it is compressing, and the reaction force is opposite to that. So it is acting in this direction. This is RB. So this analysis you have to do. So we have to find the direction of reaction force. Now in this case, so one thing, so there is unknown reaction force. Here is also reaction force, and it is also asked to find reaction at supports. So to find this RA and RB, so now we have to devise the mechanism for that. So first of all, so we know, so for solving any kind of this kind of problems, so we need to use one, equilibrium equation, second, compatibility equation. So equilibrium equation, it is depend upon the forces acting in horizontal direction, vertical direction, and third dimension if it is 3D in third direction, and also moment. So these involves in the equilibrium equation. And second category of problem, here we have to use compatibility equations. So compatibility equations are depend upon the conditions. So condition means here in this problem that kind of condition is here. So this is constrained here, and here this is the condition. Means this entire structure or two bars will not move beyond this boundary, this side or either this side. So it remains within this boundary, and the deformation of the individual member occurs. How it occurs? So this is the condition. So elongation in steel bar is equal to elongation in aluminum. So this is a compatibility equation we can call, and this is equilibrium equation. So thus, so we need to write one equation, equilibrium equation, and second equation relevant to the compatibility equation. So once you are familiar with this phenomenon, so you can solve any kind of problem. So only thing is, you remember, you have to apply equilibrium equation, compatibility equation. Compatibility equation is depend upon the conditions of a particular structure. Now in this structure, two ends are rigidly fixed. So within this rigid fixed portion, what happens? So that rule you have to apply here. So it depends upon the configuration to configuration, but you need to find the compatibility equation. Once you know the compatibility equation, I will go quickly. So I have already solved. So this is the mechanism involved in this problem. Now here, first apply equilibrium equation. So if RA and RB are the reactions at the ends, so already I have shown the previous figure. From the conditions of equilibrium, RA plus RB is equal to 30 kilonewton. You can see here. So RA is acting in this direction towards left. RB is also acting towards us. So these are acting in one direction, and this 30 kilonewton is acting in opposite direction. So therefore, sum of the reactions is equal to the force acting on the member. Therefore, RA plus RB we have written. So this is, you understood in engineering mechanics, you might have performed such as n number of calculations. So first equation, equilibrium equation, you write RA plus RB is equal to 30 kilonewton. So I will call this as a equation 1. So this is the equation 1. So we got from the equilibrium equation. Now second concept. So from the free body diagram, AC and BC are the elongations of AC equal to elongation of AC is equal to shortening of BC. Same thing. So we talked about. So this is called compatibility equation. So you apply the compatibility equation. I will write compatibility equation simply comp. So you pronounce this as a compatibility equation. Here see, elongation in steel bar is equal to elongation in aluminum bar. The nature of elongation is different, but this is a compatibility equation. So you find out the elongation in bar. So you know the formula for elongation in previous lecture. 2 lectures back we have derived this PL by AE. For AC member, so this is the amount of force PL by AE. PA is equal to RA, reaction force. So this is P is reaction force it is acting, and L is the length of the member, and A is the cross-sectional area, pi by 4 into D square into, so this material is steel, its Young's modulus is 200 into 10 raised to 3 Newton per mm square. So this is Young's modulus. So this part belongs to Young's modulus, and this is the area. Similarly, so we have to find the shortening of BC. So this is shortened by some distance, and it elongates by some distance. So that we have to find out, and both elongation and this is one and the same. That is equal to RB into 400 upon pi by 4 into 20 square into 70,000. So this gives you a elongation in second bar. So according to the compatibility equation, deformation in member 1, so that is member AC, is equal to deformation in member CB. So that we have calculated here. Deformation or elongation, one and the same. So AC So this is the value, and BC, this is the value. So here there are two unknowns. So you simplify this equation. After simplifying this equation, you will get this equation. So that is RA is equal to 1.143 into RB. So here you will get a second equation. So that equation is, so this is the second equation. One equation we obtained from the compatibility equation. Second equation, first equation obtained from equilibrium equation. Second equation is obtained from compatibility equation. Now we have two equations. So that is, so these two equations are solved simultaneously. You know the equation how to solve this simultaneously? R. So we know, otherwise you know, RA plus RB is equal to, so this is 30 kilonewton. So this equation is obtained from equilibrium equation. Now this equation is written in this form: RA is equal to 1.4. So you substitute here RA value, same thing it is done here. You substitute this value. So here RA is equal to 1.143 RB plus RB. So RB as it is, and 30,000. Now solve this. So 2.143. So this will give you 2.143 into RB is equal to 30,000. So I will write here, instead of writing 30,000, I will write 30K. So RB is equal to 30,000 upon 2.143. So you will get the value of RB, this in terms of Newton, and RA is equal to in terms of 16,000 Newton. Sum of these two must be 30,000. Now you can check up this 14 plus 16, you will get 30. So thus you will get RA and B. So we solved for unknown reactions, RA and RB. Once you know the RA and RB, second task is to determine the stresses in the member. The stress can be computed by using the simple equation. As you know, sigma 1 is equal to force upon area. So force acting on steel member and cross-sectional area of steel. So this is first for. Second, so this is force acting is RA is 16,000 Newton upon pi by 4 into d square. That is equal to 200.7 Newton per mm square. And stress in aluminum bar is, so load in aluminum bar upon cross-sectional area. So, sorry, this is 20 square. Pi by 4 into t square, 20 square is equal to 44.56 Newton per mm square. So thus you can find the stresses and strains. So I hope I have covered all 6 category problems. So we are planned. So these are all simple stresses and strains. So members subjected to different loads and the computation of stress and deformation. I hope so all of you have a ability to solve such kind of problems now. If you have any doubt, you can call me individually, or you can post me the comments on the screen or on WhatsApp. So I will answer to the questions, whatever queries you have. So that so I will do whenever you have a doubt. But I think I will not take more numericals, because for one numerical hardly it will take 10 to 15 minutes. So that's why it is because of time limitations, we cannot cover more number of numericals. I will give you some numericals in the form of assignments. So you solve those assignment and substitute. Now we have covered these 3 kinds of numericals. So let us move to the second section. So that is determinate and indeterminate structure. Yes. Anybody? Yes. Yeah. We are sharing this. Everything we have sharing. Last year notes I have already shared on the group, and this year, sorry, this week notes I will share at the end of this week, and Saturday or Sunday you will get. Definitely you will get all these notes. Don't worry. Apart from this, I am going to share the notes prepared by other college peoples also. So you will get a lot of notes. So simply, so you have to work, hard work, and you understand each and every concept. You have to solve more and more problems. Okay. Okay, you will get the notes. Don't worry. Now, next part of this lecture is determinate and indeterminate structures. So a structure refer to a system of connected parts used to support a load. Example of structure is, so you can call a ship as a structure, aircraft frames, tanks, pressure vessels, mechanical systems, and electrical supporting structures are all called as a structures. So they are subjected to loads. Such structures are composed of one or more solid elements arranged so that the whole structure as well as their components are capable of holding themselves without appreciable geometric changes during loading and unloading. So the meaning of this statement is, whenever the object is loaded within the elastic limit, so it will undergo deformation. So that is negligible deformation. After removing the load from the component, it should regain its initial position. So all structures. And the third point, which is related, while designing any machine elements or any structure, it involves the following major considerations. Whenever you are designing any machine element, so you keep in mind, machine element must meet the performance requirement. So what for it is designing, so that should meet the requirement. One. Second, machine element must carry load safely, so it will not fail. So for which load it is designed, it has to carry those loads safely. This is the meaning. Machine element should be economical in material construction and cost. It's a economical one. Its cost should not be more. So, fourth point is, machine element should have a good appearance. These are the four things. So we have to incorporate in any one of the machine element, or it may be a structure or machine element. These are the points which are belongs to common category. And also, for complete design of a structure is outlined in the following stages. So whenever you want to carry out the design of any structure, so first of all, what we have to do, we have to develop a generalized layout. Second, investigate the loads which are acting on that member and carry out the stress analysis and selection of proper elements, and later on drawing, detailed drawing of that component we have to prepare. So this is the design procedure. In third year you are going to learn these things in detail. So because you need some prerequisite knowledge, so that's why I'm mentioning here. So about this you are going to learn in detail in third year. And also these 5 steps are interrelated, and many may be subdivided and modified. So in many cases, they must be carried out more or less simultaneously, and also understand the type of structure and its element. So this procedure is a iterative in nature. So here it will not happen in one step. There are many iterations happens. So we have to calculate several times stresses. So stresses should be within the limit. If it is within the limit, then we will go ahead. Otherwise, revise the dimension. You calculate stresses once again. So likewise, so it's a repetitive and time-consuming process. So usually, so our focus is on structural elements. So please mute your sound. Somebody's sound is on. The structural elements consist of tie rods, beams, columns, and trusses, cables, arches, and surface structures. So these are the types of structure and structural elements. So we should be familiar. And for analyzing or analysis of structural members, the principle of superposition forms the basis for much of the theory and structural analysis. Here also in previous cases also we have applied this superposition theorem. It says that the sum of the deformations in individual member is equal to total elongation of a member. This kind of the one principle we used. So this principle forms the basis of analysis. On the basis of this superposition principle, so we'll go ahead for analysis of a structure member. The requirement of principle to apply, one is material must have a linear elastic manner. So all designs will happen or occur in the range of elastic limit. Theory of structures must not undergo must undergo, this is not, strike out this. The geometry of structures must undergo small displacement. It should not undergo larger displacement. Always it has to undergo small displacement, that is within the elastic limit. And third point, so we have to keep in mind, apply equilibrium conditions. So equilibrium equation, just now we have applied in previous example itself, we have seen equilibrium equations provides both the necessary and sufficient conditions for it. Second, all forces can be determined strictly from these equations. So you should not omit any forces. So you have to determine all. And the third condition is number of unknown forces always greater than equilibrium equations. So in that case, such kind of structures are called indeterminate structures. So that this I will elaborate later on. So this is the condition for obtaining statically determinate component or indeterminate component. So this condition I will explain. So this can be determined by using free body diagram. So we have to draw the free body diagrams, apply equilibrium equations, compatibility equations, and determine all the forces which are acting on a member. And then so you have to find out whether it is a determinate structure or indeterminate structure. So the determinate structure, indeterminate structure classification is based on number of unknowns in the configuration or in the structure, and also it depends upon the number of equilibrium equations. So based on that, so you can decide whether the structure is determinate or indeterminate. So this is the condition for determining the structure is determinate or indeterminate. For a coplanar structure, so this is there is a limitation. So this condition is applicable only to the planar structures, coplanar structures, where, see here, if R, I will take R is equal to 3n. So where R is number of forces and moment reactions on the components, and where n is the number of parts. So depend upon the reaction force and number of parts, the structure, whether it is statically determinate or indeterminate, so that we can decide. This is the one condition. The additional equations needed to solve the unknown equations are referred as compatibility equations. Already is we dealt with this such kind of equations, compatibility equations. Why it is required? So to solve the unknowns. So classify each of the beams as a statically and statically determinate or statically indeterminate. So this procedure, so we have to follow. So usually structural design analysis includes, first of all, we have to determine what kind of structure it is, whether it is determinate or indeterminate. And second, loading, loads acting on the member. and its strength of the material. So that is stress, strain, and force analysis of the members. So these are the steps so we have to follow for analyzing any structures. So here we should have a basic knowledge. Already you are familiar. In case of engineering mechanics, you learned this kind of connections. So this is a diagram. In diagram, you can say this is the one kind of connection. The second kind of connection which contains rollers. Third kind of connection which contains rockers, and fourth, smooth contact surfaces. So they are represented through idealized symbols. So this is the way of representation, and our interest is here how to represent the reaction. If the member is like this, so its reaction force is acting along this line. So always it makes an angle theta with respect to a particular with respect to horizontal by referring this link. In second case, roller, so there is no horizontal reaction force. Here the reaction force is only acting in vertical direction. See, here it is represented. Similarly, some component is simply resting on the component, and the reaction force is acting from bottom to up in CG direction, that is, or where the component touches with the surface. So there it acts. This is the one. So I think you are familiar. That's why I'm going quickly. So if the mechanism is smooth pin connected roller, so again the reaction is acting from bottom to up. So if it is hinged, smooth pin or hinged, so there, so it makes certain angle. So it will rotate about this point, but so it is constrained to displace in X direction and Y direction, though reaction force only applicable in Y direction and X direction. So here there is a one more roller kind. So in case of a roller, so this direction moment is allowed, but the moment is not allowed in horizontal direction. And because of that, so this extreme end may be subjected to force. So due to this force, so moment is acting at a fixed end. So this you have to remember. And similarly, there is a one more kind of subject. So this is fixed, rigidly fixed. In that case, the reaction force is acting in horizontal and vertical direction. And so these are the things you have to remember. Based on this, you can identify whether the structure is determinate or undeterminate. Sorry, indeterminate. So for that, I am taking the basics. Now we have a structure. So the definition of determinate: statically determinate beams are those beams so in which the reactions of the supports may be determined by use of the static equilibrium equation. So here the static equilibrium equations are sufficient to calculate the forces acting or reaction forces. So this is in nutshell. The static equilibrium equations are sufficient to calculate the reaction forces in a member. Such members are called determinate structures. Indeterminate structure, a static equilibrium equation is not sufficient to solve the reaction forces. Some additional equations are required for solving or for finding the